Hey, geometry students. In this lesson, we are going to be taking a look once again at translations. Now, you may remember there was a previous lesson we learned about translations, reflections, and rotations. This is going to be a sequel to that lesson where we're going to combine what we learned about translations with what we learned about vectors. And we're actually going to translate things along vectors. A translation is known as an isometry, which means that we move something around without changing its shape and size, okay? And in this particular isometry, we're going to slide an image from one place to another without rotating it. And when I slide it, I should be able to slide it back and without spinning it around, make it line back up with its original image. That's what a translation is. Let's get started looking at some examples of this. Letter A line segment has endpoints A 11.5 and B 4.9, and it is translated 5 units up. So if I were going to draw this line segment, it would start at 11.5 and go back to 4.9. It's going to look something like this. Okay, not perfectly. I'm not putting it on a grid or anything, but it's going to look something like this. When I translate it up, all I'm doing is I'm moving it up 5 units. Okay, now how am I going to do that? Because I'm moving all of the points on this line segment up 5 units. That's a lot of points. There's an infinite number of points on a line segment. So I'm not going to be able to move all of the points individually, but what I can do is take the two endpoints, move the two endpoints up, and then just connect those two endpoints with a line segment in between. So that's why it only asked me for the coordinates of the two endpoints. And when we deal with polygons, it's only going to ask me to do the vertices, because if I shift the vertices and then I redraw the polygon between the new vertices, or the line segment between the vertices, between the endpoints, it's going to shift all of the points because all of the points will be correctly in their new location if I get the endpoints and vertices to the new location. So if I'm sliding a line segment up 5 units, what's going to happen to the coordinates? The coordinates are going to go up. So the up coordinate, the y coordinate, is going to go up 5 units. It's going to increase by 5. So the new position of this will be at 11, 10, 4, 14. Let's just make sure I did that right. 11, 10, 4, 14. Please note the notation. Note that my pre-image was what I started with before, and it was just point A and B. For my image, I have A prime and B prime because it's after it's been moved. All right, let's take a look at letter B. I'm not thrilled with letter B because the y value is too big to fit on this graph, but we're just going to plot it on this graph using red points. Okay, so the first point I need to plot is at 2. The x-axis counts up by 2 on this graph, so it's right there, and then up to 5. 2, 5 is going to be my first point. This is going to be a triangle, so there's going to be 3 of these. The next one's at 1, which is halfway between 0 and 2, and then all the way up to 11. Now I'm just going to have to estimate where 11 is going to be because it's going to be off the chart. Here's 9, here's 10, and 11 is probably like right there. Okay, and then lastly, we're going to do 5, 7. By the way, don't be as sloppy as I am here. I'm just going off of what I'm provided from the book. But when you're making a graph on your own, you should be able to make it so all your points actually fit on the area of the graph. Okay, so this one is at 5, 7. The next thing I'm going to do is connect all 3 of these vertices with line segments because we're actually dealing with a triangle. Okay, let me just make sure we've got this down. And then let's go ahead. So connect from here to here, from here, there, and from here to there. I tried to make it red before. For some reason, it didn't stick. Let me just change the color of this so that it's really easy to see against the background here. Okay, there's my triangle. Now, the next thing I'm going to do, I'm going to find a way to select my triangle. All right, I have to deselect everything else. Okay, and I'm going to do something you can't do on paper. You would, in order for you to translate this, you're going to have to draw a new one. For me, all I have to do is copy and paste. And look, I'm translating. It's translating all over the place because I can just slide it around. Okay, now What we need to do with this one is move it so that after the translation, it goes -2 in the x direction and 1 in the y direction. We could have also said I'm moving it along vector -2, 1. Let's do that. So I'm going to drag it back to its original position. There we go. And I'm going to go 2 to the left. So that's right there because my x-axis counts up by 2s. And then 1 up. That's going to be here. So my primes for this image are going to be, this is going to be the actual image, and the pre-image is down there. All right, so that's how that one moves. Hey, if I wanted to draw a vector on my graph to show how that one moved, it's really easy for me to do that. All I need to do is anywhere on the graph, start a vector, and then make it show that we're going over 2 to the left and up 1, okay? And then the other thing I'm going to have to do with this is put an arrow on the end so you can see that it's actually a vector. This vector demonstrates how all of my points moved. Over 2 to the left, up 1. And I can put this vector anywhere on the graph I want. It doesn't matter where the starting point of the vector is. It doesn't affect the starting point of these points. It just tells me what direction and how far they're going to move. All right, let's move on to letter C. In letter C, it says, find the coordinates of the vertices of the image of the parallelogram ABCD after translating the vector by 3 to the right, 1 up. Okay, so I'm just going to note what each point is, and we'll just do this one point at a time. A is at point 2, 4. I'm adding 3 to the x, so 3 plus 2 is 5, and then 4 plus 1 is 5. So the first new point should be 5, 5. Notice all I did was I added this number to the x coordinate of the first, this number to the y coordinate. Let's do B next. B is at 7, 4. I'm going to add 3 to the x coordinate. It's going to slide to 10, and then up 1 from 4 to 5. There we go. Letter C is at point 10, 6. It's going to slide over by, it's going to slide to the, to the right by 3. So it's going to be 13. And then it's going to slide up 1 to 7. And then lastly, D. D is at 5, 6. It's going to slide over to 8 and then up to 7. And that is how you do this. If I'm sliding by a vector, sometimes a vector is going to be given in this form where you have an arrow. Sometimes it's going to be given in vector notation. Sometimes it's going to be given in this notation here where it just says x minus 2, y plus 1. But what you need to do with the vector is just figure out what the x is, figure out what the y is, add the x to the x, or subtract if it's negative, add the y to the y. All right, then lastly, letter D. In an animated cartoon, the UFO shown, let's just zoom in to see this UFO a little closer. It looks kind of like a cloud. It will move across the screen to the right. The animator translates 2 points of the UFO from 1, 3, and 4, 3 to an image at 9, 4, and 12, 4. What is the component form of the vector that describes this translation? All right, so we're going to answer this question by considering what the vector is going to look like if I'm moving it over a certain amount and up a certain amount. And keep in mind, when I say over and up, it might be to the left and it might be down. All right, so I'm going to grab my special angle bracket that I use just for vectors. It's not the left angle bracket. It's one that's a little bit more moderately shaped here. I'm going to do the same thing for the end vector bracket. There we go. Okay, and then let's figure out what our vector is going to be. From 1, 3 to 9, 4 is to the right 8. In the x-axis, I'm going positive 8. And in the y-axis, I'm going up 1. So it's just noting how far over, how far up I'm going. Let's see if that matches our 4, 3 coordinate. Did I go over 8 to get to 12? Yes. Up 1 to get from 3 to 4? Yes. 8, 1 is the correct answer for this. Let's just make sure. 8, 1. Also, just want to put that, let's just put that as a vector so you can see this form. If I go over 8 up 1, that's the same as doing this, going from this corner to this point. This is the vector along which that spaceship is going to move, okay? From the beginning point to the end point. So I'm just going to take any point on this ship and go whoop to make it move. And that is how you work these kinds of translation problems. I think you'll see this is fairly easy stuff. You should do the next problem set for next time.